Solar panels are usually arranged in groups called arrays or systems. A photovoltaic system consists of one or more solar panels, an inverter that converts DC electricity to alternating current AC electricity, and sometimes other components such as controllers, meters, and trackers. A photovoltaic system can be used to provide electricity for off-grid applications, such as remote homes or cabins, or to feed electricity back into the grid and earn credits or payments from the utility company. This is called a grid-connected photovoltaic system. Some advantages of solar panels are that they use a renewable and clean source of energy, reduce greenhouse gas emissions, and lower electricity bills. Some disadvantages are that they depend on the availability and intensity of sunlight, require maintenance and cleaning, and have high initial costs. Solar panels are widely used for residential, commercial, and industrial purposes, as well as for space and transportation applications. Smart solar modules. Smart modules are different from traditional solar panels because the power electronics embedded in the module offers enhanced functionality such as panel-level maximum power point tracking, monitoring, and enhanced safety. Citation needed: power electronics attached to the frame of a solar module, or connected to the photovoltaic circuit through a connector, are not properly considered smart modules. 14. Several companies have begun incorporating into each PV module various embedded power electronics such as maximum power point tracking MPPT power optimizers, a DC-to-DC converter technology developed to maximize the power harvest from solar photovoltaic systems by compensating for shading effects, wherein a shadow falling on a section of a module causes the electrical output of one or more strings of cells in the module to fall to near zero, but not having the output of the entire module fall to zero. Solar performance monitors for data and fault detection. Inverters. Solar inverters convert the DC power provided by panels to AC power. Power voltage curve of a partially shaded PV module, with marked local and global MPP. MPP maximum power point of the solar panel consists of MPP voltage VMPP and MPP current imp. Performing maximum power point tracking MPPT, a solar inverter samples the output IV curve from the solar cell and applies the proper electrical load to obtain maximum power. Microinverters work independently to enable each panel to contribute its maximum possible output for a given amount of sunlight, but can be more expensive. Module interconnection. A connection example: a blocking diode is placed in series with each module string, whereas bypass diodes are placed in parallel with modules. Module electrical connections are made with conducting wires that take the current off the modules and are sized according to the current rating and fault conditions, and sometimes include in-line fuses. Panels are typically connected in series of one or more panels to form strings to achieve a desired output voltage, and strings can be connected in parallel to provide the desired current capability amperes of the PV system. In string connections the voltages of the modules add, but the current is determined by the lowest performing panel. This is known as the Christmas light effect. In parallel connections the voltages will be the same, but the currents add. Arrays are connected up to meet the voltage requirements of the inverters and to not greatly exceed the current limits. Blocking and bypass diodes may be incorporated within the module or used externally to deal with partial array shading, in order to maximize output. For series connections, bypass diodes are placed in parallel with modules to allow current to bypass shaded modules which would otherwise severely limit the current. For parallel connections, a blocking diode may be placed in series with each module S string to prevent current flowing backwards through shaded strings, thus short-circuiting other strings. Connectors. Outdoor solar panels usually include MC4 connectors. Automotive solar panels may also include an auxiliary power outlet and/or USB adapter. Indoor panels including solar PV glasses, thin films and windows can integrate a microinverter. AC solar panels. Aluminum nanocylinders. Research by Imperial College London has shown that solar panel efficiency is improved by studding the light-receiving semiconductor surface with aluminum nanocylinders, similar to the ridges on Lego blocks. The scattered light then travels along a longer path in the semiconductor, absorbing more photons to be converted into current.